This conference will now be recorded.
So very good evening, students. As you know, we have started solving various problems, basically from JEE papers, and we have started all the way from kinematics chapter. So today, I have picked up few important problems from JEE 19, JEE Main 2019 paper, that is on kinematics. Basically, here in this problem, there will be projectile motion, then motion in a straight line, plane, etc. Okay, so we'll be actually continuing until we finish very important problems on this particular chapter. So today we'll be trying to solve few questions in that series. So see, you can see this first problem. A particle starts from origin O from rest and moves with a uniform acceleration along positive x-axis. Identify all figures that correctly represents the motion qualitatively. That means there is a particle which starts from origin. Suppose this is the origin. It starts moving with uniform acceleration along the positive x-axis. So you have to identify among these curves which one is correctly, or which one are, not only one, maybe more than one graph can represent the same motion. So we have to find out which among these can represent the motion correctly. So let us just take up this first figure. First figure is what? It is, see, in the y-axis or in the vertical axis, acceleration A is plotted against the time. So here the motion of this particle is uniformly accelerated motion. What does this mean? Uniformly accelerated motion means what? Acceleration will remain constant. Acceleration, so this means acceleration remains constant with time. Not only time, with distance also. So constant remains constant with respect to, here, since the graph has been plotted against t, we are going with time. So uniformly accelerated motion means acceleration is constant throughout the whole motion. So this figure actually is representing the motion. Look, this is the acceleration at 0 when at the origin it started with an acceleration, uniform acceleration, and this acceleration remains the same throughout the time. Okay, that's why this is going to be correct. Now let us see the figure B. So this is actually VT curve. That means velocity is plotted in the vertical direction and time is plotted in the horizontal direction. So this is velocity against time. So what is the variation of the velocity with respect to time? You can look here. See, when the time was 0, velocity was 0. When the time is increasing, velocity also increases. And that increment is actually uniformly, it is increasing with a constant slope. You can see that with a constant slope. So here we have to, if we find out the slope, you'll see the slope of this curve, slope is constant. Slope is constant. You can see that slope will be the same everywhere because it is, and that slope obviously it is looking like, see, tan theta is equal to y by x, y by x, right? Y by x. So this of y and this x, this is x, or here it is actually v by t. So what is this slope representing in the vt curve? It is acceleration, v by t or dv by dt. Since it is a straight line curve, we can take even v by t also, straight line curve. Okay, if it is like this, some curvature, then we have to take dv by dt. Okay, so in this case the slope is remaining constant. That means acceleration is constant in this case also. Slope in slope, that means the acceleration is constant. Slope, that is the acceleration of the particle is constant. Okay, so this is also correct. Now let us check this one. So here the only clue point is that the acceleration is uniform. That is the only clue. With respect to that, you have to think of. So while analyzing this graph, you can see this is actually plotted against displacement versus time. So displacement versus time, we need to understand what is the relation between displacement, what is the relation between displacement, acceleration and time. You have to find out that relation. Okay, so that we can see, the clue is that the acceleration will be uniform. Let us say for uniform acceleration, displacement is written as ut plus half at square, right? Plus half at square. So it is going in the positive x direction, and the acceleration is uniform, constant acceleration. Okay, so we are taking this as positive quantity. This is positive quantity. So you look, this x is, or displacement is actually proportional to t square, proportional to t square, with a positive slope, with a positive slope. Okay, so with a positive slope. Okay, so so this curve is actually showing some cases. See, it is fine that it is starting from here. See, displacement is starting from here at t is equal to 0. Actually displacement should be starting from 0 itself, right? So at t is equal to 0, displacement was 0, right? There was no initial displacement. Since it has started from origin, this point should be here. So one discrepancy we can see. At the same time, see, this is not this one. Okay, in fact this is correctly represented by this curve. Okay, so this is actually x is x versus t square. This curve is representing properly. So this is not true. Otherwise all three are correct. Okay, all right, so this is actually a parabola. Okay, y is equal to x square, a parabola. But this is inverted parabola, kind of, that this is, there should be a minus sign, etc., but it is not the case since it is moving in the positive x direction. Okay, so then look, this is a, this is b, and this is d. These all three are correct, so the option D will be the correct answer for this question. Okay, I hope you have understood this. You can solve such kind of problems as many as possible to make your uh, concept much more clear. So we'll go to the next question. So this question is also from straight line motion only. So here the there is a graph you can see here. So the graph is representing that a particle starts from the origin at t is equal to 0. So at t is equal to 0, so it is actually vt curve. Vt means velocity versus time curve. This is a velocity versus time curve. So in this vt curve, uh, the particle moves in the positive x direction. So here also moves in the positive x direction. Now the graph of velocity with respect to time is shown in this figure. What is the position of the particle at t is equal to 5 seconds? So this question has been asked in JEE Mains 2019. So here there is a particle moving from origin, and it is starting from rest, we can assume, and the particle is moving in the x direction, and the vt curve for that is given in this particular graph. You have to find out the position of the particle after t is equal to 5 seconds. So look here in this vt graph, if we want to find the position, suppose I have initial position, suppose I have to find out the position at some time t, when I know the position at this, since it is a straight line motion, if I know how much distance is traveled, I just add that distance, right? This is the position at t is equal to 0. In fact, it is 0 since it is starting from origin. So you have to find out the distance itself, because distance and displacement in case of straight line motion, okay, straight line motion, distance and displacement is going to be the same unless it is moving backwards, okay, unless it is moving backwards. So in this case, it is always moving in the positive x direction, so no worries here. So what you have to do, we have to find out the distance is travel during this 5 seconds. How much distance it is traveling during this 5 seconds. So what will be our attempt? We have to find out the distance traveled by the particle during 5 seconds of journey, okay, of journey. Okay, then what we can do, x of t at any time t will be x t is equal to 0 plus d. So this will be the position along the x-axis. So what is the distance? How do you find out distance from a graph? Actually, distance is area under the vt curve, area under vt, v versus t curve, okay, area under vt curve. So now look, we have to find out up to here, right up to here, right up to here. So what is the area? So we can just think of a small portion like up to here. If we think what is the area, we have to find out the area of this triangle, that's all. So triangle, so area, so suppose this has area a1, so a1 will be half base into height. What is the base is actually 2 half base into height, right? What is the height? Half base into height. What is the height? Height is 2, because this is the height, this is 2. So we get 2 meter square. In fact, it is v into t. So v means meter per second into time. So it will give you meter. Okay. So that's what. This is the meter. Okay. This is actually area means actually d1. I should say d1. It is not area in that sense. Area under the vt curve means distance. Okay. It will give you the distance. So let us get this distance as d1. Okay, so we have got distance d1. Now up to this we have got up to 2 seconds we have got. Now we have to see in between this. Okay, in between this you can see this is actually a square. So area of the square, length and breadth. What is the length? Length is 2. And what is breadth? Again, breadth is also 2. So it has, suppose distance d2, so this is 4 meter. So d2 is 4 meter. Very simple. Now you have this much area. Okay, this much area to find out. So what is the area? This is actually this is a rectangle. You can see that all the way. You have to find out this area. Okay, this area. Okay, so this total area, this will give you the total area. So this, suppose the distance is d3 here. Okay, d3. So between this, what is the difference? This is 1. So breadth is 1 and length is what? Length is actually 3. So 3 into 1. So it is going to be 3 again. d3 means d3 is again 3 meter. So what is the distance then? Total distance d1 plus d2 plus d3. We can just add them up. We could not do the integration because this is not a straight line curve. There are actually various places there are slope changes. So d1 plus d2 plus d3 in meter. So d1 is 2 meter. D2 means 4 meter. Again, d3 means 3 meter. So as a whole, it gives 9 meter. So what is the, after 5 seconds, displacement will be, or position will be at t is equal to 0, x is equal to t is equal to 0 plus d. So what is the position? Position at t is equal to 0 was 0, and this is 9 meter. So ultimately 9 meter will be the position along the x-axis. So the position will be 9 meter from the origin, 9 meter away from the origin. Okay, so here option C will be the correct answer. All right, I hope you have understood this also. Now we'll go to the next question. So this is a very important question and very interesting also. Just we have to read it carefully and then we'll solve it. So in this problem, what is stated? It is stated that so these are actually H1 and H2. These are suffix H1 and this is H2. So there are two particles. So two particles are projected from the same point with the same speed. From the same point, from the same speed u, such that they have the same range but different maximum heights, H1 and H2. Which of the following is correct? So these are the relation between the heights and the maximum heights and the range, horizontal range. So out of these 4, you have to find out the correct one. So let us first understand the problem. This problem is stating that there are two particles, okay, both are actually thrown from this origin, okay, but you can just look this, they are actually having the same range, same horizontal range. Let us say this is r, but their heights are different. So this much, suppose this is h1 and this one is h2, this height is h2. One more thing, if you look, you can understand that both the particles are not thrown at the same angle. If this is thrown with angle theta, then the other one must be thrown at an angle 90 minus theta. You can just think of that, okay, from here, or 90 plus theta. Let us say this is theta, this is theta, okay, this is theta, okay. If or either one of that will be theta, so you can just think like this. So someone is thrown with theta, then the other one is thrown at an angle this. So this is the one. So this can be actually stated in another way also. How? If this is, suppose this, the smaller angle is theta, so this can be actually measured from this side also, right? We can then say 90 minus theta. Is it okay? So up to this is theta. So in fact, these two are actually not thrown at the same angle. So there is the clue. Okay, there is the clue. So one is thrown at angle theta, then the other one is thrown some other angle. Okay, not exactly the theta. Okay, so this is theta. The other one, with respect to this, actually we can write, in fact this is with respect to this, if you write, then 90 minus theta, right? So that is what we can write. Okay, so we have obtained here the formula for the range with capital R and maximum height with capital H. We can now write what are H1 and H2. Let us say for H1 it is thrown at an angle theta, so we can use this formula. So u square, both are thrown with the same velocity. So let us write this is sine square theta divided by 2g. So what about H2? H2 will be u square sine square, this is 90 minus theta, okay, 90 minus theta. At this angle it is thrown at 90 minus theta divided by 2g. So this actually gives you u square cos square theta divided by 2g. Okay. Now this is the range. Now we can write the range here. Let us write the range here. Range is actually given by u square sine 2 theta divided by g. So I can just break this sine 2 theta by writing 2 sine theta cos theta. So 2 u square sine theta cos of theta without breaking any generality. Okay. Now look what we can do. We can just square them out, square both side out. So you'll get 4 u square e to the power 4 sine square theta cos square theta divided by g. Now look, I am trying to just write this particular factor, this right hand side in terms of h1 and h2. If we try to do that, see, you have here only u square sine square theta, right? So you have to just strike this, and in the denominator you have to have h1 and h2, right? So there should be 4g, and here e to the power 4, and these are fine. So look, I'm just writing on, see, I'm writing u square sine square theta by 2g, again another u square sine, sorry, this is cos square theta by 2g. So this 4 was there already, and what extra I have written? I have written extra u to the power 4, so here e to the power 4 is there. Sine square theta, here sine square theta, cos square theta, cos square. What extra I have written? I have written 1 by 4th extra. So I just multiply 4 so that this 2 will get cancelled with this 4. So finally what we are getting, this is 6 into, see, this is h1 square, I'm sorry, this is h1 and this is h2. So we can write h1 and h2. So which one is the relation which is correct? That is this one. Use r square is equal to 16 h1 and h2. Okay, 16 h1 and h2. So here only clue was this one, that one is, both are not projected at the same angle. If one has been projected at theta, the other one is projected at 90 minus theta angle. Okay, so by that we are able to solve this problem. Okay, so the answer is this one, B, option B. Now this is another problem which is already being discussed somewhat, not exactly this problem, but we have discussed a problem related to the trajectory of a projectile motion. So here, see, there is a problem in this in 2019, that the trajectory of a particle near the Earth's surface, near the Earth's surface means g can be taken as 10 meter per second square or 9.8 meter per second square, near the Earth's surface is given as this. So this is the equation of trajectory. Okay, EOM of trajectory is given. Okay, this is the trajectory, equation of trajectory. If it were launched at an angle theta 0 with speed v0, so this is the angle of projection, this is the initial speed v0, and g is given as 10 meter per second square, then which among these four options will be correct? Whether theta 0 will be sine inverse 1 by root 5, and v0 will be 5 by 3 meter per second, etc., etc. So you have to find out which one is the correct answer. So it is very simple. So see, this is the trajectory given. So you have to write the trajectory which is known to you in terms of this. So we know the trajectory can be written. General formula for the trajectory is x tan theta minus g x square by 2 u square. The initial velocity here it is v 0. Sorry, here it will be the v 0. Here it will be v 0 square. Okay, into cos square theta. Okay, gx square by 2 v square. This is the general formula. So if we compare this equation 1 and our known equation 2, then what we get comparing 1 and 2? What are the outcome we are getting from here? See, comparing this part, this 2x minus 2x, so 2x minus this with this is resembling with like this. So the x is common in both cases. So what is what? So tan theta can be written as 2 comparing 1 and 2. And what else we can write? We can write g by g by 2 v naught square cos square theta is equal to gx square. So is equal to here 9. Okay, this is the 9. So using these two, we have to find out the theta 0, cos square theta 0. Here it is theta 0, cos square theta 0. Let us just go to the next page. What we have got? We have got comparing the equations, given equation with our known general formula for the trajectory of a projectile. So we have got tan theta is equal to 2. Okay, and what else we have got? We have got g by 2 v naught square cos square theta naught is equal to 9. Let us first understand this tan theta, and see here there is a term cos theta square. So if we know somehow, if we can find out cos theta out of this relation, then it is very simple. Look here, tan theta is 2. That means I can just draw a equilateral triangle. Suppose this is a 90-degree angle. Okay, even though it is not looking like that, but still you just compare. As I just think, so if this is the perpendicular and this is base 1, see, we get tan theta is equal to, and suppose this is the angle theta. If this is the case, then tan theta is equal to this. That means tan theta is equal to 2. So we can write this as, and what will be, so these are 1, suppose 1 unit and 2 units are the values of the two sides of the triangle. So we can write here actually 5. This is the hypotenuse of the triangle. Okay, so look, this is actually base square plus square root of base square plus base square means 4, and this is, sorry, this is perpendicular square plus base square. Base square is 1, so it is this. Okay, square root of this. Anyway, we have got this. Now from this figure, can you find out what is cos theta? This is very simple. Cos theta is base by hypotenuse. Cos theta base by hypotenuse. So base by perpendicular. Okay, I'm writing clearly again. Base divided by perpendicular. Length of base by perpendicular. What is the length of base here? Length of base is 1. and perpendicular is 2. That's why it has become like that. Okay, tan theta is equal to, then what we can write, oh I'm sorry, this base is 1, this is not perpendicular, you have to write hypotenuse over here, hypotenuse for cos theta, hypotenuse is actually root 5, right? Base by hypotenuse, is root 5. So you look what you have got, cos theta. So what is theta? Theta is cos inverse, okay, cos inverse. So theta 0, here it was theta 0, suppose theta 0, so theta 0 tan theta, and here theta 0 also we have got cos theta 0 is equal to 1 by root 5. Now look, we'll just solve this problem here, putting cos theta over here. See, look, g is 10 meter per second square, that is given already. V square, V naught square, we have to find out. Let us keep that as it is. Cos square theta 0 is equal to 9. So this is 5 meter per second square. And let us do one thing. We'll just take this V0 square cos square theta is equal to 5 by 9. Okay, now what is V0? V0 will be root 5 by 3 divided by cos of theta. So if this is cos theta means 1 by root 5. 1 over root 5. Cos theta means 1 over root 5. Just put the value, cos theta value from here. Root 5. 3 into cos of theta means 1 by root 5 again. So it will make it 5. So this is 5 by 3 meter per second. Okay. So what you got? You have got theta 0 is equal to theta 0. Theta 0 is equal to theta 0 is equal to cos inverse 1 by root 5 and V0 what we have got is 5 by 3 meter per second. Okay, so these are the answers. You can see from here there is theta 0 is equal to this and this is, so this option C will be the correct answer. Obviously we'll check and confirm with the other also. See, this is not there. Fine. Excuse me, so this is sine inverse, so actually this is the correct answer. 5 by 3 should be there, not 3 by 5. Okay, so we have solved this problem also. This is very simple, but you have to actually do it carefully. Okay, and this is the clue you have to use, otherwise you cannot you may find it difficult to find out the theta value. Okay, so now we'll just take up one or two more problem. Let us see according to our convenience. Let us write the problem. There is a problem here, so this is problem number 5. In 3 dimension, I'm writing in short, in 3D dimension, that means 3D system, 3-dimensional system, the position coordinates, the position coordinates of a particle in motion. Particle in motion are given below. What are given? The positions are given. So position coordinates. Suppose x is equal to a cos omega t, then y is equal to a sin omega t, and z is equal to a omega t. Okay. So the velocity, you have to find out what would be the velocity. The velocity of the particle will be the velocity of the particle will be number one, first option, root 2 into a omega. Option B, a 2 2a omega, 2a omega. Option 3, option C is a omega, and option D is saying that is root 3 a omega. So how to solve this problem? So you have to find out the velocity. So how to find out the velocity? We have to actually find out the velocity like this, dr dt. So what is r here? What is r? First of all, let us write this in terms of, so this is answer. This is a clue to the answer. So first of all, what is r? Vector x I cap, y cap j, sorry, y j cap, z k cap. Okay. Now what is x? We'll just put it here. A cos of omega t, then a omega, sorry, a sin omega t, a sin omega t, and this is with j cap, and with k cap, a omega t k cap. So if you want to find out the velocity, what you should do? You should take the derivative, right? I'll just write the r vector, a cos of omega t I cap, b, sorry, it is a throughout, a sin omega t j cap, and a omega t k cap. Okay. So if you want to find out really what is velocity, then you have to just take derivative, time derivative. Okay. So time derivative means here, what is that? Minus omega a sin omega t. I cap plus a omega cos of omega t j cap, and here t will go off. Okay, so this will be actually the velocity, and here you can see I can write Vx as, this is V vector, so I can write Vx as a minus a omega sin omega t. Vy I can write as a omega cos of omega t. Okay, and Vz is actually a omega. So if you want to calculate the modulus of this vector, velocity vector, you have to take square of each component and sum them up. So what is this Vx square? So a square omega square, a square omega square sine square omega t plus a square omega square cos square omega t. Okay, and finally you have a square omega square. So this sine square theta omega t or cos square omega t both will actually add up to 1. So you will get this. So this is 2a square omega square, right? That means root 2a omega. So this will be actually the modulus of the velocity, root 2a omega. So here look in the options, root 2a omega is the first option, and that will be the correct answer for this question. Okay, this was not very not very tough, it was very simple. Now we'll take up the last problem for today. We'll just take up the last problem for today and then we'll stop. Okay, uh, let us write the problem first. This is sixth problem. These are all actually from 2019 JEE Mains paper. So a particle is moving with a velocity v is equal to, this is a vector, v is equal to k y I cap plus x j cap, where k is a constant. Okay, so k is a constant. The question is, the general equation for the path is, the general equation for its path, equation for its path is, there are few options. Option number A, y is equal to x square plus constant. Option B, y square is equal to ax plus cos theta, sorry, plus constant. Option C is xy hyperbola, xy is equal to constant. And option D is y square is equal to so y square is equal to x square plus cos theta, sorry, constant. So you have to find out among these four which one is the correct answer. Okay, so what do we do for this? What is given? Velocity is given. Let us say the component of velocity along x direction is what? Y, and Vy is along x, right? Now look what we can write. We can write V x by Vy is equal to dx by dt divided by dx by dy by dt. This is what we can write. I'm just clearing it. So Vx means dx by dt, very simple, and Vy means dy by dt. So this dt goes off, you get dx by, what you get? Dx by dy. Again, Vx by Vy is what? Vx by Vy. Let us now write dx by dy. We have got Vx by Vy to be is equal to y by x. Now from here, what we can write? X dx is equal to y dy. That, sorry, y dy. We can write this. Okay, so what we have got, I'll just clean this portion. Okay, let me just keep it here. Otherwise, you'll be getting confused. I'll repeat what I have done so far. See, I have just got the components of the velocity along x and y direction. Vx is equal to y and Vy is equal to x. That is one part. Another part is Vx by Vy means dx dt by dy dt. Okay, so this dt goes off and dx by dy you get. Now what is Vx by Vy? We have got Vx is equal to y and Vy is equal to x. So y by x. If we get y by x, and see this is dx by dy, so we just take this side by, okay, and then integrate them with a constant, integration constant. So what we are getting? Okay, look, we have got y dy is equal to x dx. Let us keep the constant in this side, in the right hand side. Any arbitrary constant. So y square by 2 is equal to x square by 2 plus this constant c. Okay, so you just multiply 2, y square is equal to x square plus, with constant, if you multiply then you will get again the constant also. Okay, so y square is equal to x square plus constant. This will be the correct answer. So the fourth option, option D will be the correct answer for this question. So with this, I'll stop it here for today. Again, we'll be meeting on Tuesday. So on Tuesday, or let me see, if possible, I'll take another class on Friday, if possible, or otherwise we'll be back on Tuesday with this same chapter. We are actually planning to finish all the questions from JEE Mains on this particular topic, kinematics. Okay, so bye for today. Thank you for your patience.